Hi everyone, and welcome to this walkthrough video in which we will be taking a look at how to go about writing up your analysis section in your research paper. Your analysis needs to be reliable, like your data. So, yeah, there are a number of reasons why you might unintentionally misinterpret your data. You might choose the wrong data to answer your research question, or you might not really understand what the limitations are. You could believe you see a pattern that is really just a coincidence, or you might analyze a small amount of data and incorrectly assume that the result generalizes to all cases. So let's just talk a little bit about causality. Now, when we say something like, cancer rates are higher near oil refineries, what we usually mean is cancer rates are higher because of oil refineries. But as the old saying goes, correlation is not causation. When does correlation, an apparent relationship between things, indicate causation? One thing causes another. Let's take a look at a pretty humorous instance of when one thing does not lead to another. Not two, we'll look at just one graph. Okay, so here we see on the vertical axis the number of portions of ice cream sold. Here on the horizontal axis, we see the number of murders, the months of the year, May, June, July. Here we see, okay, so in May, we see the number of murders rise right through June and then up as well in July. So there's a steady upward trend in the number of murders across these months. Interestingly, we also see that the number of ice cream portions sold rises as well. So it's logical, right, to assume that ice cream consumption leads to murder. Well, no. It's pretty clear that in this case, one occurrence does not actually lead to or cause the other. The two data sets just happen to be similar. We have two data sets here, ice cream sold and murders. Okay. For research purposes, correlation just means there's a pattern of some kind in the data. The thing is, after you have found any correlation between A and B, you, the researcher, still have to prove that A causes B. That is, you can see a pattern, but that doesn't mean it's proof that one thing causes another thing. Let's look at this graphic image on how correlation happens. All right, we have variable X causes variable Y, or vice versa, Y causes X. We can also see that there may be a variable Z that causes X and causes Y. We may also have a hidden variable. We don't know what it is, but it's having some influence. It causes X and causes Y. And then there's just random chance. There's no relationship between X and Y. There are a few ways that two variables can end up correlated. Okay, suppose we discover that countries with more guns have more gun homicides. Think, what are some of the many variables that could correlate these two facts? That is, why might countries with more guns have more homicides? Can we automatically assume that the higher number of guns causes the higher number of homicides? Obviously not. There are other variables at play here. So, all right, let's play a little game. Can you match the statements above to the correct picture? We have random chance, X causes Y, Y causes X, a hidden variable causes X and Y, and here we have gun ownership causes homicides. People will use guns to kill if they own them. Homicides cause gun ownership. People will buy guns and use them if they live somewhere dangerous. Something else causes both homicides and gun ownership, perhaps poverty. And it's just a coincidence. There is no causation. Take a moment, pause this video, and see if you can match the statements above to the correct picture. All right, here are our answers. Well, what we see is X causes Y. Gun ownership causes homicides. Or Y causes X. Homicides cause gun ownership. What about a hidden variable? Something else causes both. And here, random chance, there is no causation, it's just a coincidence. The easiest way to prove causation is to rule out all other possibilities. Now, first, you should try to rule out coincidence. As a researcher, you must make a case for why the variables are not only related, but actually one leads to another. You need to make an argument based on the data as to why it's not just a coincidence. If this is too difficult, then as a researcher, you are obligated to make this clear to the reader in your limitations. We'll talk about these next week. That way, sorry for the typo, capital T, you are covering your back, so to say. There's also a very helpful video here that you can watch for further explanation. And the video is indeed about correlation and causation, and it's 5 minutes long, and it features a hamburger. So I hope that this walkthrough has helped make sense of writing up your analysis section. And thanks for watching.